Happy Friday, happy Fruit Snack Friday, chemists. I just want to talk today about today's topic, which is pretty interesting. I think you're going to enjoy it. And I want to look at your periodic table, and I want to look at three elements. So if you can look either on your periodic table or on the wall, I want you to find lithium, sodium, and potassium. And what you think about, and this will be a question you can answer right now, so you can take a second, how many protons does each of these elements have? So take a minute. So hopefully you came up with the answers 3, 11, and 19, right, for these three elements. Now, I'm going to ask you another question. How many energy levels, right? So we think back to where our electrons live, right? They live on the outside of the atom. They live in what we called energy levels. We thought of it as a hotel, right? And so in that hotel, there are floors, and each atom has a different number of floors depending on where it's at in the periodic table. So take a look at your periodic table and see if you can tell me how many energy levels each of these atoms has. Hopefully for lithium you said 2, sodium you said 3, and potassium you said 4, right? So now what that means is if we look at each of these atoms, right, in the middle of each of them is the nucleus, which is where the protons and neutrons are. Right? But around each of those are our energy levels. So for sodium, it looks like this. 2 energy levels. For potassium, for lithium, like that. And then we should move this one down. Right? It's going to be 1, 2, 3, and 4. Okay? So now I want you to imagine that you're an electron at the outer edge of the atom. And by the way, these electrons have a name. They are called valence electrons. A valence electron is any electron that lives in that outermost ring of the atom, right? So for lithium, the valence electrons would be the electrons in the second energy level and so forth, right? And so for this one, any electron in the third energy level would be called a valence electron. So we look at this and we know that the nucleus, if it has protons in it, what charge would it have? Hopefully you said positive. Electrons, we spent time on this, but we know that they are negatively charged. And so there's an attraction between positive and negatives. And so there is a force of attraction pulling in on these electrons, right? So that force, though, decreases as you get further away from the nucleus, because the thing that's attracting them is getting further and further and further away. You can think about this as a long-distance relationship, right? Someone that you are in love with right here at Evanston, if you move apart, there's a chance that that attraction will diminish because the distance between you has increased. The same thing's here. As this distance increases, the attraction for the nucleus decreases, right? So this electron has a pretty strong attraction to the nucleus. This electron, meh, eh. And this electron has a really weak attraction to the nucleus. And so what we see is as you go down a family, and so if you find these three, lithium, sodium, and potassium, you'll see they're in the same family. As you go down a family, the force that's holding the electrons gets weaker and weaker and weaker, which means, and we're going to see this in a demo, that if I want to come and take this electron, which one would it be easiest for me? If I say I was a water molecule, because we're going to do a demo with water today, say I was a water molecule, which one would it be easiest for me to take? Hopefully you said this one, right? And so that idea of how easy it is to take an electron is something called electronegativity. Oh, sorry. How easy it is to take an electron? is what is known as an atom's ionization energy. The easier it is, the lower this energy would be. Okay? Now, last thing I want to talk about is I want to look at lithium and beryllium, right? Now, they are two members of the same row, right? If you find lithium and beryllium, they're two members of the same row, which means they both have two energy levels. So the electrons, and I made these blue, but here they're black, the electrons. That's just arbitrary. But I'm going to draw one electron in the outer energy level, the valence energy level for each of these. Now, in this case, the electron's roughly the same distance away from the nucleus, but in lithium, the nucleus has 3 protons, and beryllium, the nucleus has 4 protons. So let me ask you, in which of these two is this electron feeling a stronger force of attraction? You should say the beryllium one. So what we would say as chemists is beryllium has a higher ionization energy than lithium. And so the pattern is very simple. As you go down a family, so I'm going to say as you go down, ionization energy, IE, decreases. But we see here, as you go over, ionization energy increases. And we'll actually work with this today and do a lab with this, but this is the idea, the concept for today's class.